Now, the big guy on the block, insert injection molding. So there's a lot of things on this screen, so I'm going to go a little bit in detail and start from the right top area. So we have our end result product, which is a pair of sunglasses. You don't see through them, they're all plastic. They're probably molded in black plastic. So below that, you see one half of the cavity insert, okay? And then below that, you see the same insert with a protection surface draped over it. And we're going to talk in detail about these protection surfaces and how they're used to machine the inserts, but mainly, primarily, what they're used to protect the parting line. And if you move over from there in the middle, you see two examples of injection molding defects. On the right, you see flash, which can occur if your parting line has been sufficiently degraded. So you need to take care of that parting line, and we're going to show you how to do that. And then on the left shows a mismatch in the parting line. Now, the mismatch can occur if your tolerances aren't tight enough, if your setup is not correct, things of that nature. So on the right, we got the flash, which is caused by degrading of the parting line. And then on the left, we have mismatch, which can be caused by incorrect setup or incorrect tolerances. So let's move directly above that. Now, a subset of cavity and core inserts in a mold. Obviously, you think of a mold, you think, okay, we're just going to blow some plastic in it, and then we're going to have a part, and then everyone's hunky-dory. But that's not the case. You will have a prototype mold, which will create some prototype parts. Your engineering customer will review those molds. They'll make changes. They'll take the parts. They'll mark them up. They'll actually take a marker and write it, write on the part. Say I want more material here. I want less material there. We need to make revisions. So the mold maker will make sets of inserts. So he's probably going to machine at least 2 sets and possibly even more, just for that purpose, for revisions and whatnot. And if those revisions get to such an extent that the mold cannot be revised anymore, either by adding material into the mold, and this is done regularly, they're actually in a typically welding process where they'll add material into the cavity so that they can remove it, with revisions in it, or more precisely, they can cut holes in that insert using a wire EDM machine to get a precise insert measurement where you can redesign an insert to go in the insert, which contains the revision. So this is, primarily the reason why precision is the utmost concern in plastic injection molds. Now on the far left,
just a note here, I just wanted to let you know, Don in his previous life was a mold maker, and so just wanted to let you know he knows what he's talking about. So just to give him a little bit of encouragement here.
Well, just a note here, I could only hack mold making for 2 years. It was very, very demanding. And you guys know, if you're making molds, especially if you're in the automotive industry or aeronautics industry, it's a very demanding profession to be in. So hats off to you guys for being able to stick it out longer than I was able to. Okay, so on the far left, if you've created cavities, then you know about EDM machining, electronic discharge machining, where you're taking a core and a cavity, and one half of the cavity is typically it's made out of graphite, and it is used to actually burn a cavity into your insert. Both the cavity and the graphite are submerged in a dielectric solution, and the precision that these two components are getting closer and closer to each other, about 4 thousandths apart, the electricity starts arcing from from your insert to your graphite, and both parts are actually vaporized in the process. But what you're left with is a perfectly formed cavity that you don't need any finishing, you don't need to do anything else. So this is a very, as long as your graphite core is machined properly, that's exactly what you're going to see in the cavity. Okay, so if anybody has any questions on mold inserts, please put them in the chat window. So when we get to the demo area, we're going to be spending a lot of time on this particular part, and I'm going to show you the best way to machine those parting lines. We're going to be taking a look at some recommended techniques for programming injection molding cavity inserts and core inserts. In this video, we're going to introduce the use of what we're calling protection surfaces. These are added surfaces in your model that help protect the parting line during machine toolpath generation. Okay, so I've got a simple insert on the screen. We have one cavity, we have a parting surface, and it is exploded to be a poly surface. It's not a solid. In order to edit the surfaces, you need to explode your solid. So what we're going to do first is we're going to program this without the use of protection surfaces so you can see the cut material simulation at the parting line. So we're going to go ahead. We have the roughing and the re-roughing already completed. So we're going to go ahead and create a 3-axis parallel finishing operation. And we're going to go to the Part Surfaces tab of the Control Geometry tab, and we're going to select the surfaces, and we're going to pick our 4 cavity surfaces, and then right-click. For the surfaces extent condition, you can set it to on, to, or past. On means that the center tip of the tool will go to the parting line and line up with the surface edges, which in this case is the parting line. The to option means that the diameter of the tool will stop when it lines up with the boundaries of the surface, which means that your cutting point, the tip, will not go all the way to the end of the surface, so we're not going to use that. The past option is where the diameter of the tool goes past the surface boundary and stops when it touches the other side of the tool diameter. Also, we don't want to use that because we want to keep the tool off of these parting surfaces. So we're going to use the on condition. And for the tool, we're going to use a 3/8 inch ball mill. For the cut parameters, we're going to set the intolerance to 0.0005 and out tolerance 0.5. And this is 1/2 of a thousandth, and the reason is that we're going to set our advanced cut parameters to 1,000. So we're starting with the advanced cut parameters and we're setting it to 1,000, and then in the cut parameters we're setting it to 1/2 of that. That's what we recommend. So also for the cut parameters, we're going to have a mixed cut direction, start at the bottom. We're going to have an angle of cuts of 0, which means the cuts will traverse back and forth in the x-axis. And for the step over, we're going to make it 5 thousandths. Typically, you may make it tighter in production environments, but we're setting it to 5 thousandths just for show. So we're not going to change the Z containment. The entry and exit tabs, we'll leave all those the same. And for the advanced cut parameters, as I mentioned, we set the before mark fitting to 1 thousandths, and let's generate that. Okay, so let's look at the toolpath. We see that we have cuts running along the x-axis. The dark blue are arc motions, and the light cyan are linear motions. And we see that the tool goes up and aligns with the parting line. Okay, so let's go ahead and also change the color of this operation for when we simulate it. Okay, so now we got one parallel finishing operation. We're going to clone that, and we're going to use it again, and we're going to change our cut direction to 90 degrees. So it'll be right angles to the first one. And here's our toolpath in the Y direction. Now what we're going to do also is we want to program toolpaths for the parting surface themselves. We'll make a copy or clone a copy of the last parallel finishing operation. We're going to edit it, and we'll go to the Part Surfaces tab. We'll remove those, and we're going to select the parting surfaces. So we'll select surfaces. We'll pick our parting surfaces, work our way around, and right click. So here's our parting surfaces that we're going to machine. We're going to use the same on condition where the tool will go up to the parting line or the edge of the insert and stop. Everything else is going to be the same. We're going to leave that cut angle at, we'll set it to 0 like the others, and we'll pick generate. So here's our parting surface parallel finishing, and we're going to change the color of this to a darker blue for contrast. So we've got our first parting surface parallel finishing completed. We're going to clone that, and we're going to edit this one, and the only thing we're going to do here is we're going to change the cut direction to 90 degrees to traverse in the y-axis. So there's our parallel finishing in the y-axis of the surface parting surface machining. Okay, so we got those. Let's go ahead and look at the simulation and see how that looks. So let's go ahead and we'll just simulate them individually. There's our roughing. There's our re-roughing. Here's our first cavity parallel finishing going in the X direction. And then here's our second cavity finishing going in the Y direction. Okay, so there's our cavity finished, and let's go ahead and simulate the parting surface in the X direction and in the Y direction. So the tool is going up to the parting line, and the tip of the tool is stopping when it aligns itself with the parting line, and the same occurred in the cavity. So let's take a look at this. Let's look at the top view, and we see not so good a parting line. We got some overcutting here. This will probably end up with flash in these areas here as well as right here. And let's go back and look at the isometric view again. So you see how the tool rode up on to the parting line and cut into the parting surface. So if you look, here's the parting line here, and here's the cut. So it went up to it, and when it stopped, it started cutting into the parting surface, which, you know, that would be a flash area and not a very nice parting line. And on the other side, you see that it rode the parting line even further. This is the parting line. So the tip of the tool was here, and it gouged out part of your parting surface. That's not a very good parting line. If you try to mold a part with that, you probably end up throwing the parts away. We don't want to do that. Okay, so there is the typical method of machining a cavity in a parting surface. Now what we're going to do is we're going to show you what happens when you use protection surfaces. Again, a protection surface is just a regular surface, but what it does is it protects the parting line. That's its sole purpose. It keeps the tool from riding on the parting line rolling over the parting line or riding along the parting line. So if you refer back to in our slide presentation, the first contact rule states that whenever that tool makes first contact with the parting line, that's it. It doesn't contact that point again. It doesn't roll on it. It doesn't do anything. It just contacts it and just keeps on going. And that's in both for the cavity areas and for the parting surface areas. Okay, so let's go ahead for the protection surfaces. We're going to create a couple of layers. We'll say surf1-cavity. And we'll create one more. Call it surf2. Okay, for our parting protection surfaces, we're going to go ahead and make a copy of these cavity surfaces. And we're going to copy them to this layer. So what we're going to do now is we're going to activate that layer, turn our other layers off, and you see that we have just the cavity surfaces. What we're going to do, Rhino provides a command that allows you to untrim a surface. So instead of the trim surface, this surface will extend out to its full extent, untrimmed. So we're going to go to the Rhino surface menu, go down to Surface Edit Tools, and we're going to select Untrim. And it's asking you to select an edge. So we're going to pick this edge. So you see how the surface extended out. We'll pick this edge, and that edge. So there's our cavity surfaces untrimmed. And let's go ahead and escape out of that, and we'll just change the color of these protection surfaces, just so we have some contrast. Okay, so there's our protection surfaces for the cavity. So now we'll go over to our layers. We will activate Surf 2 and turn off protection surfaces for the cavity, and then also turn on the part itself. So what we're going to do here is we're going to create some parting surfaces from the edge geometry that we have. So the first thing we're going to do is we're going to go to Surface, Extrude Curve, Straight. So what we're going to do is we're going to extrude these edge curves right across the cavity to cover it. So we're going to pick this edge, this edge, this edge, and this edge here. And we're going to right click, and you'll see that it's extruding in the default direction of the parting surface. So what we want to do here is we don't need to know exactly how far it's going to overlap. We just need to make sure that it's at least a half of the tool radius. So we're going to bring it over a little excess. You see that you can see through the surface. That's because it's upside down. So we'll select them and type in flip, and that turns them right side up. And then we're going to select them again, and we're going to drag them across the top of the cavity. So what we have is the cavity completely covered over. That's what we mean by protection surface. Now also we're going to be machining these edges of the parting surfaces, so we want to extend surfaces out on each side. So we're going to go to Surface, Extrude, Curve, Straight. This time we're going to extrude the edge of the parting surface, protection surface we just created. We'll right click, and you'll see that by default it's going in the vertical direction, but you can change that by selecting the direction option from the command line. And we're going to pick 2 points to determine the direction. And then we're going to slide out the surface in that direction. Again, it's flipped upside down, so let's go ahead and select it. Select flip, and that'll turn it right side up. So we're going to do the same thing, Surface, Extrude, Curve, Straight on the other end. And for the direction, we're going to pick 2 points, and we're going to extend that out there. So here's our parting surface completely covered with a protection surface. So what we're going to do is we're going to go to the top view, and we're just going to select those, and we'll change the color. There. Okay. So now we got our protection surfaces created. There's our cavity protection surfaces, and there's our parting surface protection surfaces. So now what we're going to do is we're going to use the same operations, and we're going to regenerate those with the protection surfaces displayed. So we're going to go ahead and select all 4 of our parallel finishing operations. We're going to copy, and we're going to paste. So these have another copy, and we can go ahead and suppress these so that we don't accidentally use them or edit them in any way. So we're going to go into our first cavity parallel finishing operation, and what we're going to do is we're going to you can either leave the part displayed on or off. In this case, we do, however, have to turn off the parting surface so we can get down to the cavity. So we're going to edit that, and we're going to go to the Part Surfaces tab. We're going to remove all of those, and we're going to select the protection surfaces. There. So in this operation, it's going to go all the way. It's going to ignore the parting line. It's going to go right past it and go right to the edge of our protection surface. Let's go ahead and generate that. So you can see how the toolpath went right past the parting line, right up onto the boundary of the protection surface. So let's do that again for the second cavity operation. Go to the Part Surfaces tab, we'll remove all, and we'll select our untrimmed protection surface. Right click and then generate. So there is our toolpaths for the cavity using protection surfaces. Now let's go ahead and edit the 2 for our parting surfaces. So if we're going to turn off our protection surface for the cavity and turn on our protection surface for the parting surface. So we're going to edit the first operation in the parting surfaces. Go to the Part Surfaces tab. In this case, we don't need to change our selection. We're going to leave it the same boundaries as it was before, and it'll just ride over our protection surfaces. So we're going to go ahead and pick Generate. And we're going to go to our second parting surface operation and pick Generate. So there's our parting surfaces. Let's turn off the protection surfaces so you can see how it goes past the parting line. Actually, for this one, we want to go ahead and make an edit here. Let's go back to the Part Surfaces tab, and we're going to use the past condition. Now in this case, because our protection surface is displayed, we can use the past condition because it'll go past the parting line and stay out of the cavity because we have this protection surface displayed. So we're going to generate that, and then we're going to generate this one also and change it to past and generate. Okay, so let's turn off our protection surfaces so you can see how it travels past the parting line onto our protection surface. Okay, we've got all of our operations completed. Let's go ahead and simulate those. We need to regenerate our roughing, and then we will simulate our roughing. Then we'll regenerate our re-roughing, and we'll simulate our re-roughing, and we'll turn the toolpaths off so we get a good look. And now we're going to skip our locked operations, go right down to the parallel finishing operations that we used with our protection surfaces displayed. Now again, the only thing you have to do is make sure your protection surfaces are visible. You don't have to select them in any special way. As long as they're visible on the screen when you generate the operation, they will affect your toolpath. So let's go ahead and simulate our first parallel finishing in the cavity. And we'll simulate our second parallel finishing in the Y direction of the cavity. So now we're going to simulate the parting surface toolpaths. We're going to simulate that in the X direction and then also in the Y direction. Okay, so let's look at the top view again. So now you see a real clean and crisp parting line. Let's go into the isometric view and you'll see that there's no over bleeding. The tool is not riding over the parting line. It's not these colors are not bleeding one into the other. This means that the parting protection surfaces did their job and forced that tool to ride directly over the parting line without stopping on it, without rolling over on it, and without rolling along it. So all you want to do is to have that tool touch the parting line and then move on. So we hope this short video helped you to understand some methods that we recommend for machining inserts, injection molded inserts, cavities, and parting surfaces and parting lines.